Hi all, welcome to another video on post-tutorial recall after 1 hour class. And in this video, we'll be looking into balancing redox equations as this is a new type of balancing that you are learning in matriculation. So let's get started. So here's the question. Okay, we are going to use the ion-electron method since it's the redox reaction. And the example I have given here is actually a disproportionation reaction. So what do I mean by disproportionation reaction? Is that a single species, okay, is simultaneously oxidized as well as reduced, as you can see over here. So there's nothing to be worried when you see questions like this because it does exist, whereby a single species can be oxidized or reduced. Okay, so let's have a look at how do we solve this in the basic medium. So first of all, we have to identify which species is undergoing oxidation and reduction. So the easiest way is to look at the oxidation number. So for a neutral molecule, the oxidation number is 0, and we all know Cl minus has got an oxidation number of -1. So that's a clear-cut reduction over there. Thus, from Cl2 to ClO4 minus would be oxidation. So balance the half equations separately. As you can see, I have balanced them clearly. So what do we have to take note? First, make sure to balance the number of atoms and then balance the charges. So in this case, we have got chlorine 2. So I have multiplied here by 2. And oxygen, as you can see, we have 4 oxygen on the right. There is no oxygen. So I have to introduce 4 water molecules on my left, which at the end introduces 8 hydrogen on my left. So I have introduced 8H plus on my right. So please remember, when we want to introduce oxygen, we have to use water, and if we want to introduce hydrogen, we have to use H plus. All right, so once the number of atoms are balanced both sides, left and right, what do we do next is we make sure the charges are balanced. I've taught you in class whereby we look at the overall charge and multiply it with the stoichiometry coefficient. So on the left hand side is 0, whereas on the right hand side it sums up to +6. Always make the bigger number become smaller. So how do we make 6 become 0? We have to -6, and I keep telling you there is no such thing as minus in chemistry, it's all plus. Therefore, we have to plus 6 electron, which is equivalent to a -6 charge, which gives the right hand side a total of 0 oxidation number, and the left hand side is 0. So that's balanced out. Next, we are going to combine both the equations together. How do we combine? We make sure the number of electrons on each equation is the same. So that would be multiplying the reduction equation by 3. Okay, please not forget writing all your physical states. And once you have done that, okay, as you can see, I have got a nice clean equation. And please remember, this equation is only the acidic medium equation. Now the question wants us to do a basic medium, so we continue by adding equal number of OH minus to the H plus ions, both on the right hand side as well as on the left hand side. And the next step is just to beautify the equation, I say. Okay, merge H plus and OH minus together, which results in 8 water. Now you must realize that water is also on the left hand side of the equation. So bring them all together, right? So bring the lesser towards the more water on the right hand side, and there you have it for H2O on the right. The other species, the other ions remain as they are. Okay, so I hope that's a good recall for what we have done in class.